Okay, let's unpack this. Have you ever considered if there's a fundamentally different way to understand the universe? Something beyond what mainstream physics usually teaches. Today we're taking a deep dive into something truly, well, audacious. Randell Mills' Grand Unified Theory of Classical Physics, or GUTCP for short. You've come to us, maybe new to this subject, wanting to know if this theory is valid, and more specifically, what you can conclude about its validity based solely on the sources you've shared with us.
That's right. And our source material for this exploration is a pretty comprehensive series of detailed evaluation reports. These were all penned by Dr. Randy A. Booker, who's a physicist. He meticulously reviewed dozens of chapters from Dr. Mills's really extensive book. So our mission here is to distill Dr. Booker's findings and, well, see through his eyes what the evidence he presents actually suggests about GUTCP. And what he found is quite remarkable.
Okay, so let's start right at the foundation. When Dr. Booker looked at GUTCP's approach to fundamental particles, their interactions, things like, say, the humble hydrogen atom, what did he discover?
Yeah, what's really fascinating here is a consistent theme right from the get-go. In his initial evaluations, Booker focused on the most basic building blocks. He successfully replicated calculations for fundamental quantities, like the Land-D factor for the electron and muon, that's a measure of how particles interact with magnetic fields, and parameters for single electron atoms, like hydrogen. He verified many of the theory's core equations. His results, he actually noted, were in excellent agreement with Dr. Mills's values and, crucially, with experimental data. He even highlighted agreement to a very high degree of accuracy across multiple tables in the book, like tables 1.1 through 1.5. He basically concluded this was a clear validation of the theory's foundational claims.
So the absolute basics checked out. That's definitely a strong start. But what about more complex atomic behaviors? Like how atoms react to external fields or, those all those internal forces causing subtle energy shifts?
Right, building on that foundation, Dr. Booker then moved into examining how GUTCP handles the more, let's say, nuanced behaviors of atoms. He verified calculations for the hydrogen atom's ground and excited states, including phenomena like the Lamb shift, that tiny but really important energy difference you see in atomic spectra, and things like spin-orbit coupling, which describes how an electron's spin interacts with its orbital motion. He reported, and I quote, remarkably good agreement, pretty much across the board. He only noted some minor discrepancies which he thought were probably just due to his own rounding. So again, this pointed towards a striking consistency in the theory, according to his review.
That is impressive, especially when you think about how delicate some of those measurements are in the real world. And what about the electron itself and how light photons interact with matter? I mean, these are absolutely fundamental to physics.
Absolutely. So for the free electron, Dr. Booker confirmed the derivations for concepts like its charge and mass distribution, and how something like the Stern-Gerlach experiment's results, that famous experiment showing the quantized nature of electron spin, are actually predictable within this classical framework. Then, moving on to light, he verified GUTCP's derivations for photons, things like their energy, momentum, radius, wavelength, frequency. He noted that GUTCP shows wave-particle duality, which we often think of as this big quantum mystery actually arising classically within the theory, and is consistent with well-known effects like the photoelectric and Compton effects. Now, what's really surprising, maybe even startling, is this prediction of what Mills calls photon torpedoes. The idea is that energy emitted as a photon isn't diminished in intensity over distance.
Hey, really? No diminishing intensity?
According to the theory, yes. Think about that for a second. Light getting weaker over distance is like a fundamental assumption in current physics. If these photon torpedoes are real, it would completely upend how we understand light propagation and energy transmission across vast cosmic distances. It's a huge claim. Dr. Booker also confirmed the theory's explanation, based on something called the House non-radiation condition, for why ground state and these proposed hydrino states of hydrogen don't radiate energy, and that this is consistent with Maxwell's equations.
Okay, here's where it gets really interesting for a lot of people listening, and maybe even controversial. This claim of new, lower energy states of hydrogen, these hydrinos. Did Dr. Booker find validation for their existence in his review of the theory?
This is definitely a pivotal point for GUTCP, yeah. And Dr. Booker's reports are quite direct here. He verified the calculations related to hydrinos. These are, as you said, newly predicted hydrogen energy levels lying below the conventional ground state. They're characterized by fractional quantum numbers, like 1 over p. He confirmed the calculated potential energies in the figures were consistent with the theory, and he verified all the values in the relevant tables, 5.1 and 5.2. And here's the kicker. Dr. Booker actually mentions firsthand evidence he personally observed between 2005 and 2015. Evidence showing the existence of hydrinos and the excess energy release when they form. He explicitly states in his report that laboratory evidence points to their existence.
Wow, first-hand observation mentioned in the
Right.
report. Okay. And how does the theory explain the stability of these proposed new states? Or even connect them to huge cosmic phenomena like dark matter? That sounds like a massive leap.
It does sound like a leap, absolutely. But Dr. Booker's review shows the theory does attempt to connect these dots.
Yeah.
It delves into the conditions under which atomic states radiate energy versus remaining stable. Dr. Mills proposes that reactions forming hydrinos could actually be responsible for dark matter, and maybe even some gamma ray bursts we see in space. Dr. Booker verified the calculations for things like spin slip energies and frequencies for different hydrinos, and also spin nuclear and orbital nuclear coupling. And he found very good to excellent agreement with his own calculations. So according to his review, this suggests an internal consistency, even when the theory makes these broader cosmological claims.
All right, this next bit. This is where things often get tricky in standard physics, right? Quantum mechanics, for instance, it frequently relies on approximations, especially for atoms with more than one electron. What does Mills' theory offer here?
That's a really important question, and it's an area Dr. Booker specifically highlights as a truly amazing feat of the theory. See, while standard quantum mechanics can only solve multi-electron systems like the helium atom or the hydride ion using complex approximation methods, GUTCP apparently provides exact, closed-form solutions, no approximations needed.
Exact
Solutions for helium.
Exactly. And Dr. Booker reported excellent agreement between Mills's calculated ionization energies for these systems and the actual experimental values. He even made a point of noting that quantum mechanics' approximate results aren't very close to experimental values even then, which is quite a statement. And this success, according to his reports, extends even further. It covers the excited states of helium. We're talking over 100 energy levels. He found GUTCP's closed-form solution showed utterly outstanding agreement with experimental data from places like NIST across numerous tables. So this implies, well, potentially a fundamentally different and maybe more precise underlying model for how atoms actually behave. Okay, utterly outstanding agreement is strong language. It really sounds like GUTCP is making some incredibly powerful claims about atomic and molecular structure, offering precision where other theories need estimates. What about chemical bonds and more complex molecules, the actual building blocks of our world?
Yeah, the reports just continue this trend of, well, surprising accuracy and breadth. Dr. Booker verified calculations for various hydrogen-type molecular systems, things like molecular ions, H2 plus OH2, even dihydrino systems. And again, he found remarkable agreement with experimental values for both the energies and the distances between atoms. This then expanded out to excited electronic states of diatomic molecules. Here, the calculated values showed remarkably close agreement to experimental data, with really impressively small relative errors, sometimes as little as 4 parts in 10,000 for certain excited states.
Tiny differences. From simple atoms to pretty complex molecules, the theory seems to cover a lot of chemistry. Did it go further? Did it venture into something as vast as organic chemistry or even solid-state physics, the stuff that governs the materials all around us?
Yes. It absolutely did. Dr. Booker's review covered organic molecular functional groups, things like alkanes, ethers, alcohols. Calculations for energies and bond distances were verified there too. Then it applied the theory to systems like sodium hydride, water vapor, graphite, even solid noble gases like helium and neon. And the finding was consistently remarkable agreement with experimental results. He also looked specifically at carbon allotropes, diamond, fullerene, graphite again. Remarkable agreement reported for their bond energies and parameters. The review even went into ionic and metallic bonds, like in alkali metals and hydrides or halides. There, the lattice energies and distances were verified with good to excellent agreement compared to experimental data. And apparently this was even independently confirmed by other reviews mentioned in the source material, like from a Dr. Mark Nansteel.
And what about semiconductors? They're so crucial to, all our modern technology.
Indeed. Dr. Booker's review extended to silicon molecular functional groups, and specifically the semiconductor bond in silicon. He found remarkable agreement for solid silicon parameters, and notably excellent agreement between GUTCP's calculated band gap energy for silicon and the known experimental value. That's a really key property for semiconductors. This comprehensive molecular scope also covered things like boron compounds and organometallic compounds, with consistent accuracy reported across the board in those chapters too.
Okay, the theory calls itself grand unified, which implies it reaches far beyond just atoms and molecules. Does it really extend to the very big, like cosmology and the fundamental forces that, shape the entire universe?
Absolutely, and Dr. Booker's reports confirm this ambition. He verified GUTCP's derivations for fundamental statistical mechanics, things like Maxwell-Boltzmann, Bose-Einstein, and Fermi-Dirac statistics, showing they are valid within the theory's framework. He then reviewed applications to specific, kind of weird quantum phenomena like the quantum Hall effect and the Aharonov-Bohm effect. These are effects that show quantum mechanics influencing macroscopic properties. And again, he consistently found remarkable agreement with the observed experimental behavior in those cases too.
But what about something as profound as, say, creating matter from energy? Or even the very nature of space and time itself? These concepts feel so abstract, almost belonging purely to relativity.
Right. Well, for creating matter, Dr. Booker verified GUTCP's theory of pair production. It shows how an electron-positron pair can be created from a photon, while making sure all the conservation laws, energy, momentum, charge, are consistently maintained. And on the nature of reality itself, this is pretty unconventional. He verified that spacetime within GUTCP is modeled as an LC circuit at resonance.
Electrical circuit. Spacetime.
Yeah, basically like a fundamental electrical circuit. Its oscillating energy could, according to the theory, explain the very fabric and behavior of space and time. It's a very different picture. He also examined positronium. That's a system made of an electron and its antiparticle, a positron. GUTCP calculates its ionization energy and excited state energy levels, which, according to Booker's check, perfectly match the experimental values. And the hyperfine structure of positronium, which is a very, very precise measurement, also shows remarkable agreement to 6 significant figures in his review.
Okay, perfect matches and agreement to 6 sig figs. So what does all this mean for Einstein's theories? Relativity, gravity, these are absolute cornerstones of modern physics. How does GUTCP interact with those huge theories?
This is a crucial question, especially if you're familiar with the current physics framework. Dr. Booker's review covered GUTCP's deep dive into relativity and gravity. He verified the derivations for special relativity, including things like time dilation. For general relativity, he confirmed calculations for phenomena like the precession of planetary perihelia, that subtle shift in the orbits of Mercury, Venus, Earth, and the bending of light by the sun. He noted that GUTCP's predictions align with observations where good old Newtonian physics falls short, just like general relativity does, so it matches observations there. But here's something particularly fascinating. Dr. Mills proposes reinstating absolute space within his theory.
Absolute space, like Newton thought.
Kind of, but seemingly integrated differently. The idea is to resolve paradoxes, like the twin paradox, while still conserving mass energy. It's a bold move against Einstein's framework. Dr. Booker's concerned that the calculated mass ratios for fundamental particles like the electron, muon, and tau, and even the neutron, derived from this framework, show remarkable agreement with experimental values. And here's another really striking point from his review of these chapters. Dr. Mills apparently put forward that hydrinos could make up dark matter and predicted the accelerating expansion of the universe 25 years before it was actually observed.
Predicted the accelerating expansion 25 years early.
That's what Dr. Booker's review of Chapter 32 states, yes. If accurate, that's a massive prediction.
Okay, that is a huge claim, predicting such a fundamental discovery decades ahead of time. And what about the very smallest things, the fundamental building blocks, quarks, and even the possibility of totally new forces?
Yeah, the theory continues its reach right down into the subatomic realm. Dr. Booker reviewed this concept of pseudo-electrons within GUTCP. These are proposed particles with negative gravitational mass, which leads to a proposed fifth force, one that would be repulsive, kind of the opposite of gravity. He verified the mathematical framework for this. Then the theory addresses leptons and quarks. GUTCP successfully calculates the masses of the electron, muon, and tau leptons, and also the masses of the 3 quark generations of neutrons, all, according to Dr. Booker, in amazing or excellent agreement with experimental values. His review also noted that Chapter 36 predicted the mass of the X17 particle at 17.11 MeV. That's a particle that has seen some recent, though still debated, experimental support. And finally, GUTCP tackles nuclear forces and radioactivity, beta decay, alpha decay, even the nature of neutrinos. And consistently, Booker reports finding excellent agreement with experimental data for energies, masses, and decay constants.
So It's a lot to take in. It really seems GUTCP touches upon almost every single area of physics, from the tiniest particles right up to the largest cosmic structures. What does Dr. Booker's review indicate this all means for the prevailing theory for quantum mechanics, which is so widely accepted today?
Right. The reports, especially in the later chapters in the introduction to Mills' book that Booker reviewed, consistently highlight areas where GUTCP presents itself as, well, a more successful alternative to quantum mechanics. Dr. Booker noted that GUTCP uses a classical electron radius that's finite, not zero like in standard QM, and that this is apparently supported by scattering experiments. For wave-particle duality, Mills argues, and Booker reviews this argument, the classical physics can explain phenomena like the two-slit experiment, where QM often resorts to, probabilistic interpretations. According to Dr. Booker's review, GUTCP claims to resolve some long-standing thorny issues in quantum mechanics, things like the infinities that can pop up in quantum electrodynamics, or the really perplexing collapsing wave function idea, think Schrodinger's cat. It apparently does this by having a finite electron radius and a continuous representation of electron states, rather than probabilities collapsing. Dr. Mills' theory, as verified mathematically by Dr. Booker in his review, provides a classical explanation for the EPR paradox, the aspect experiments, Bell's theorem.
Stuff QM describes as spooky action at a distance. The source material of the introduction chapter Booker reviewed explicitly outlined what Mills sees as QM shortcomings, like its failure to predict spin from first principles or its inability to apply exactly to multi-electron atoms. And it contrasts these with GPCP's claimed successes across, get this, 85 orders of magnitude of phenomena, from galaxies way up here down to the subatomic world way down there.
Wow. Okay. So, based purely, and we have to stress this, purely on Dr. Booker's extensive evaluation reports that you shared with us, it really sounds like Randell Mills' grand unified theory of classical physics offers a remarkably consistent and successful framework across an incredibly broad range of physics, with calculated values often matching experimental data with pretty stunning accuracy.
That is precisely the conclusion you draw from reading these specific source documents, yes. Dr. Booker's consistent verification across literally dozens of chapters, verification of Mills' calculations, his equations, his predicted values, often, as you say, to a very high degree of accuracy, frequently described as remarkable or excellent agreement with experimental data. It strongly suggests, at least from Dr. Booker's perspective as presented in these reports, that the theory is indeed accurate, valid, and reproducible in all the many domains he reviewed. And he really emphasizes how it offers these exact solutions where quantum mechanics often has to rely on approximations.
So, if you came to this deep dive new to Randell Mills' grand unified theory of classical physics, maybe just wanting to understand if it's a valid theory, what can you reasonably conclude from these specific source documents provided? Well, they certainly present a compelling case, based on Dr. Booker's detailed verification, for the theory's mathematical consistency and its predictive power across a truly stunning range of phenomena, which of course raises a really important question, doesn't it? If this classical theory, as documented in these reports, is so successful at matching experimental data and even claims to resolve some of quantum mechanics' long-standing issues, why isn't it more widely recognized or taught in mainstream physics? That's definitely something to ponder.